So, as promised, we've got the Mustang 3000 today, which is 2 inches wider, and you get a Delta tune knob. Well, wasn't that really worth the extra tenner at the time, which makes them a bit rare. And the width of it is, wow, you know, it's something again, that is. I don't know what kind of car you have to get put that in. Anyway, unfortunately, it's another set that comes with no power connector. Now, what we've done is one of my contacts has driven over 11 miles, and he's brought one off a scrap set that he owns. I'm going to do him some favour in return, servicing wise, and so we can put this connector on this radio, and this will cheer up this customer no end. So let's just hope it's not being messed with. I'll put the soldering iron on ready. I'll tell you what, we'll do the service work with this tail, because it's actually easier than me not having the right power lead. Anyway, well, that's nice, isn't it? We've got the ballast resistor in place. That's a minter. Wow. Right, well, we'll connect it up to power. So in this bank bag is the connector. So I'll put that on the video. You're probably going to have to watch this tomorrow or something, because it's delayed the job hours, knowing that this is coming, and we're now well into the evening. In fact, we're now at 8:30 in the evening. Where's the mic? Where did I put the mic? The more the customer tells me about the York 863, which is the next repair from him, the worse the set sounds bodged. Well, it just about fits into the camera's normal position. Do you like the place to keep your mice? Right, well, like any set with this chassis, we need to start by doing the VCO. And like any set with this chassis, we now know it's a floating chassis, so we need to connect negative to the power supply negative. We need to switch the radio on. Even better if we got 13.8 volts. Right, there we go. PCB channel 1. I still need to look at the notes. Yeah, channel 1. So between now it's so wide we can hardly show the meter. So capacitor 9 far end, 2 volts, we'll just drop that a fraction with L1. We'll check transmit. Bring that down a bit with the trimmer capacitor. So there's our transmit, there's our receive. Now we go to channel 40. The manual says 4.5 volts. The reality is it's over 3.5-ish. 3.7 on receive, 3.2 on transmit. That is fine. I'm not sure whether they wrote the manual with the Avo 8 meter in mind, because that was the industry standard at the time. Anyway, there we go. Select the radio onto channel 20. So we have the proper ballast resistor in place. We've got the proper 5 watt version, not some silly little 2.5 watt one, or some daft Hapeth who's modified it. Not sure what that's about. Must be factory though, surely. Right, we'll select picture in picture. Three watts. We may have to adjust the ballast resistor value. Not all PAs will do 4 watts with the ballast resistor factory selected, so we'll see what happens. So we're on channel 20. We're on actually 3.2 watts. Maximum. 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 If you watched yesterday's video with the Mustang 2000, where they'd linked out the ballast resistor, because on a cheap power meter it reads the radio as about 6.5 watts. In actual fact, 2.7 watts of it yesterday was on 111 megs, which is the aircraft band. So, you know, they're not getting more around 27 megs, they're getting it on other frequencies and causing disruption. That needs a bit of melting. Can't actually see it from my seated position. Still can't get to it. No, it will not do more than that. So we're going to change 3.3 ohms for 2.7 ohms. Got a bag here of different values for when this happens. Yep, that's fine. It's the last one of these as well. I'll turn the power off. And on this we've got the, I mean, this might have changed value as well after all those years. Power back on. Let's see whether that's brought the power up. There we go. 4.1 watts. And on channel 40, 4 watts dead. And on channel 1, 4.1 watts. It's slightly lopsided. So we're probably best off. Best thing to do is to adjust that coil that's now 4 watts. Channel 40, that's now 4 watts. And channel 20 is now 4 watts. So that's balanced up a treat. See, everything's spot on. Let's put the spectrum analyzer on. Make sure, because I've changed that resistor, it could have changed the way the PA performs. So wait for that to come on. In the meantime, we'll add this to our Bible reading second-hand piece of paper. Mustang 3000 TX 3.2 watts 4 watts done. Frequency, let's put the camera on number 2. And we'll look at the frequency counter. 27,79129. How good is that? I'll just tell you what, we'll pop it on to 127. That's strange, it's gone up. It's working the opposite way to usual. You know what? The coil's broken. So it was on frequency. And when you try and touch it, it's broken. Yeah, that's got to be changed. Well, I'll tell you what. I'll just do this spectrum analyzer thing. Frequency 27,79125. There we are. And now we'll look at the 54 megs, 55 megs second harmonic. Really needs to be less than 56 dBm, minus 56 dBm. Frequency, put in 55 megs. Okay, so that's our second harmonic, and that's 55.604, and it's minus 34, so we do need to get that to come down a bit. So just check that these coils aren't in silly positions, like that one is. Placement of some of these components. It's getting better. Is that resistor in the right place? That's fine. Little bit high at what's that, minus 52. So we'll let it go at that. But that's an improvement from minus 38. And let's just check we're still doing full 4 watts. It is, yeah. We'll do deviation, I think, while we're at it. Wallow. It's only 1.5, so we'll put that on the chart. Coil. Ballast. So we need to sort that out. Deviation is 1.5. So we'll just sort that out with the oscillator. Bring that up a bit. See where it is now. Wallow. That still wants a little bit more. Wallow. Spot on. 2.2 to 2.5. And then we'll just check with the RF meter. So when we press transmit, it's reading higher than it should. That's shorted out the crocodile clips, which we're good at. See how bothered I am. There we go. Lovely. So we'll turn it off and we'll get that coil change for one off a scrap set. And that is something we will have on a scrap set because I don't often have to change things like this. So let's just suck the solder off that. I once had one of those expensive foot control operated desoldering machines, you know, like 500 quid thing. The nozzle was forever getting blocked. You know what, I don't seem to have that problem with the RS ones which we buy. They've got some good suction on those. Right, I'll pause the video and I'll recover one off a scrap set. Oh, look what I've found. I found a scrap fake Amstrad. So, for those of you who don't know, if you open up an Amstrad and the board has no writing on it, so whereas this one is a it's a Cybernet set with printed circuit board with all the component locations screen printed on it, made in Japan, that's the genuine one. If you get a Hong Kong one and all the screen printing's there, cheaper production, but it's still a real one. And if you buy yourself an Amstrad 901 and when you open it up, the board is a bare board with no writing on it, you've got yourself the fake version. So they don't normally work very well, although if you're having a collection of CB radios, you need to have a genuine 901 made in Japan, you need to have a genuine 901 made in Hong Kong, and you need to have a fake 901, and there's more of the fakes than any other type, because it's all part of the history. So where's that on the other side? Funny enough, some of the quality of the parts in these fake sets actually is better than the genuine one. Like the coils are usually Tocco. and they're a bit Billy No Mates, in my opinion, on the normal version. I don't think I got one of those legs, do you? I don't think that desoldered. Or perhaps it's me. There we go. I can go back on the floor. Pop that out. That can go in the vertical filing cabinet. Just make sure that's pushed in firmly and squarely. Notice it's had soldering around the phase lock loop chip. I'll be cleaning up all the soldering with isopropyl alcohol. Now we'll adjust this, but it'll probably want adjusting again because with it being hot, it will affect it. Let's go over to the frequency counter and see if we can get it. If I hadn't touched that, you know, I would have let this set go, and then in 5 years' time, he'd probably send it in for somewhere else for service. And they'll go, whoever looked at this last broke this coil. And, you know, just goes to show how it's best to check everything. Right, that's well out. Oh dear. We'll have to try a different one. We'll better try one out of a genuine set instead. I'm not sending it out high like that. It's within tolerance, but it's not good enough. So here, this is a genuine one, and you can see it's all screen printed. This is why we have scrap sets around, because it doesn't take much realising that after 38 years I can't exactly write to any of these manufacturers and ask for spare parts. It's nothing like doing a job twice. And that's definitely not wanting to stay in on its own. So we'll kind of hold it whilst soldering one pin. It's where I need 3 hands. Okay, see what happens now. Spot on. Okay, so that's that done. So now we'll move over to the receiver. Right, what we'll do, we'll turn the bench light off, we'll turn the oscilloscope on, we'll put the camera onto the oscilloscope, and we'll put S9 equivalent signal. It helps if I plug in the test equipment. You know what, before we do the detector, I think we just need to see what the cyanide is before we go upsetting it. To be honest, it's lousy. It's 1 microvolt, 1.2 microvolts. So that's no good. So we'll start with doing the detector. So we'll go back to what I was originally saying with the oscilloscope. To be honest, that recovered audio looks awful. Let's see whether we can improve it with the detector coil. Still got a bit of a kink in it, but that's a lot better. So now we'll do the cyanide one. We'll do these IFs first. Now we'll do the front end. What I've discovered is the delta tune control affects it dramatically, so our first result was a load of baloney. Well, how do I know what is centre? Let's go through these again. So a lot of sets with Delta Tune will have a centre position, but it doesn't seem to be a central position on this one. Okay, so we've now got, I don't know now what the original reading was because the Delta Tune was in the wrong position. I'd felt it to be in the centre, but centre isn't like normal position on this set. So it's now, it's an incredible 0.23 microvolts for 12 dB cyanide. So that's certainly the most sensitive of the three. And I would have expected them to be the same, to be honest. So let's see where that control is. It's over, look, it's over towards the right. So you can see it getting worse as we go there. So it's about that position for normal, which I find weird. Okay, so that done, we'll set the S9 on the S meter. So that needs coming down from a rather generous position. So that's now done. Now we'll set the squelch. So we'll put the picture-in-picture on the attenuator controls. Just turn down the volume a tad. And we're going to turn the signal generator down. We'll turn it off to standby. Turn the squelch to full. Squelch is now full. Turn the signal generator on. And I want the radio to come in when I get to 100 microvolts, which is S9, which is there. It comes in at 30, so I want it a stronger squelch than that. That's too strong a squelch. This is the letdown on this chassis. That's it, we're there. Good. So now at the other end, again we'll turn the signal generator off. We've parked it at 0.3 of a microvolt. Turn the squelch down. Set it to threshold. Switch the signal generator on. It's come straight in. So it's coming in at, it's just off my scale there. Just off the scale, so it's not quite coming in at 3.2 micro, 0. It's about 0.35 microvolts. If I go on the next scale, it's already there. So let's get it to come in, and it's dropping off at 0.2 of a microvolt. So that's excellent. Proof of the pudding will be in the eating. We'll see what it's like on the test, which will be tomorrow. Yeah, I'll just check we're still on frequency. No, it's drifted, you see. Let's go back to that so you just notice. So because the coil's now cooled down, we just need to pop that back down. Now that might affect the delta tune. So let's look back at the delta tune. So go back to the cyanide meter. Now let's play with the delta tune again. So worse. And that's even more lopsided now. It's ridiculous. Okay. Well, normal position is nearly towards the right. So that's working very nicely. Oh, well, just for the record, we'll just check low power. And it's 0.25 a watt. It's supposed to be 0.4. It's preset. Or it does at least work. So next thing I'm going to do is we'll just pause the camera and we'll do that power connector, and then that's the job done. Okay, so there we are with the new power connector fitted. Thank you, David, for coming over with that. And we've got the ferrite beads which he supplied with it, which are important for anti-parasitic oscillations coming in and out of the power connector. So it's the right way round. We've got the red to the bottom, and it says positive. We can zoom out again now. So now we'll have to connect our crocodile clips straight onto the back of there because we don't have a lead that fits. Let's check we're still working. Perfect. We'll look at the protection diode, which is down there. Make sure it's intact. It is intact. There we are. So it's time to put the lids on. So we've done so many of these this week that we know that the green one's negative. We won't remember this next week, but at the moment we can remember. And therefore that one's positive. It doesn't matter, but I'm just being a perfectionist. We'll just clean up where we've been soldering and where others have been soldering. Get the isopropyl alcohol out. Don't know why that hadn't been cleaned up. Having said that, we didn't have isopropyl alcohol when I was in the television repair business. But having also said that, when I was in the television repair business, some of the tellies didn't even have printed circuit boards. They were hand wired. So those of you who've been involved in television in the UK, cast your mind back to the ITT KB VC51 black and white television chassis, which was hand wired. And I think their first colour chassis, the CBC2, I recall that was hand wired, but I must say I never saw one of those. That is dry joint. This is what you uncover when you do this. Just there. So we'll do that. No, it's not. You know what would happen there if I hadn't seen that? It would have gone back in the post and the customer would have said this radio doesn't work. Okay, so it's time to screw it together. We'll plug the aerial in and see whether at 9:30 at night there's any good budgies on. Is this going to line up or not line up? This set's so big you get provision for 2 thumb screws on the side. There we go. Unplug the instruments. Put our crocodile clips back on in the right place. Plug the mic back in. I'm trying to keep this plastic sleeve on just so that I know that it's our standard Cybernet test mic. Okay, there we go. Signal generator off. I'm being careful not to touch the back and knock the power off. Well, they sound off frequency, but they always do, don't they? Because they're not on frequency, because they're on illegal radios. So I've got my mic lead caught up with my connectors, which is neatly disconnected my positive. 19er Roger. Right, we'll see how that is with a scratchy corner test, which will now be tomorrow. So you don't often see one of these. We haven't ever done a video with a Mustang 3000 before, and I think it's a very collectible set. So thank you for watching.